Hello and welcome. I thought it would be fun to build a robot and in the process integrated AI and blockchain. I hope you enjoy this video. The robot is based on Brocking's balanced robot design. The body parts were printed using a 3D printer. I extended the design by adding a Raspberry Pi and Pi camera as well as an ultrasonic distance detector. The pan, tilt, servo, and motors are each controlled by Arduino Pro Minis. After I built the robot, I thought it would be useful to show how the robot, machine learning algorithms, and a blockchain can work together in a use case where the objective is to improve the quality of an image classifier. There are 9 major steps that make up this demo. On the diagram, you see the data interactions of the robot, Jetson TX2, MQTT server, and a Raspberry Pi that represents the role of an external analyst. Step 1. The robot uses OpenCV to find images, and the output is integrated into the pan-tilt motor logic as well as the balanced robot logic in order to keep images centered and bring the robot close enough to capture a JPEG. In this demo, I'm using a tennis ball and 3D printed Easter egg. Let's watch the robot in action. Now that the robot has captured an image, let me walk you through the rest of the application. Step 2. The robot creates a blockchain record via the blockchain's REST server. The record is made up from metadata captured from an image as well as the metadata about the robot. Step 3. The robot publishes metadata on a Mosquito MQTT server. Step 4. The robot SFTPs the image file from the robot to a file directory on the Jetson TX2. Step 5. A listener program on the Jetson TX2 subscribes to the MQTT channel. The metadata has the file name, hash of the image for data integrity, blockchain record ID, and other metadata used to update the specific blockchain record via blockchain transaction in Step 6. The transaction also emits a blockchain event. Step 6. Using TensorFlow and the open source ImageNet library software, the Jetson TX2 classifies the image to include the likelihood percentage and updates the blockchain record created by the robot. Here's where the concept of a blockchain business network hopefully begins to make sense. Step 7. In this demo, I've kept the blockchain smart contract simple. It evaluates the attribute called object state name, and based on a string match, the code sets the object state to a specific term. For example, if the object name equals tennis ball, then the object state is set to sports item and updates the blockchain record entry. Once the object state is set, the transaction publishes a blockchain event on the blockchain REST server web channel with the updated metadata. Step 8. Blockchains are about business networks, and to demonstrate off-chain processing, I have a Raspberry Pi listening to the blockchain REST server on behalf of the analyst actor for events that publish the object state. The Raspberry Pi reads the event JSON, does internal processing, and will update the blockchain ledger in Step 9. Step 9 completes the cycle. For this demo, if the object state equals unknown, it opens a trouble ticket to improve the quality of the image classifier. In this demo, the Easter egg will be produced an object state of unknown because there's not enough examples in the version of ImageNet to get a high probability result. The tennis ball tends to classify correctly. If this were a real system, you might put an SLA in the smart contract to track how long it takes to create an updated classifier for images. To further clarify the business network of a blockchain, let's look at how the blockchain participants update the image record. In this demo, there are 4 steps. A blockchain is a distributed network, and each of the blockchain participants, i.e. the robot, Jetson TX2, and analysts could add their data from different nodes on the blockchain fabric. Step 1. The robot creates the green font attributes to establish the record in the blockchain. Step 2. The Jetson TX2 inserts the yellow font attributes into the record based on the image classification. Step 3. The blockchain smart contract updates the blue font attributes based on the data from the Jetson TX2. Step 4. Finally, the analyst updates the record with the quality analysis based on the smart contract. I hope you enjoyed this video. Stay curious, my friends.